Hello, Algebra 1. Today we are talking about line of best fit and correlation. So sometimes when we're looking at a group of data points, there's not a line that perfectly fits all of the points. This happens a lot in real life situations. So today we're going to look at a bunch of different problems that determine which line best fits the picture. And this is called the line of best fit. Now, tomorrow we're going to figure out how to actually find this equation with Desmos, but for today we're just going to look at some multiple choice questions. So here's how we're going to choose the correct line of best fit. Our first step is we're going to draw a line through the points. You want to make sure your line follows the trend of the majority of the points. So in this case, I'm going to draw a line like this. I'm going to determine whether the line has a positive or negative slope. This has a negative slope since it's decreasing. Then I'm going to cross out the options that have the wrong sign slope. That would be C and D because both of these have a positive 1 for your slope. Next, I'm going to circle the y-intercept or starting point on my graph, which would be right here on that y-axis, and then determine which option has the correct y-intercept. So for me, that is option A. It's at a -2, and that's it. All right, let's try it again. First, draw a line that goes through most of your points. This has a positive slope, so I'm going to cross off A and D because both of those have a slope of -2. Now I find my y-intercept, which is where I hit the y-axis. That's up at a positive 1, and so I circle this answer. Next up is number 3. Number 3, when I draw the line, it appears to be horizontal, and it looks like I'm going through like a 3.5-ish. And so I have A. All right, so next we're going to talk about correlation. So we have 3 types of correlation: positive, a negative, and no correlation. This has to do with the relationship between 2 variables. So for example, what is the relationship between how much fast food people eat and what their weight is? In general, the more that people eat fast food, the more weight they will gain. This is called positive correlation, because as one variable goes up, so does the other. You can also represent positive correlation with a graph. A graph that shows positive correlation is one that has a positive slope. So if we look at this graph, you can see for sure this graph does have positive correlation because its slope is positive. All right, now I want you to notice there's kind of a point off on its own here. This is called an outlier. Even though it doesn't follow the trend of the rest of the points, there's still a clear positive relationship between the majority of the points. So in this situation, maybe you know someone who eats fast food all the time and then just stay super skinny and don't gain any weight. That person would be an outlier because their experience does not follow the trend of the majority of people's experiences. All right, another type of correlation is called negative correlation. So what is the relationship between the temperature outside and the amount of layers that someone puts on? Well, the higher the temperature, the less layers you put on, okay? Or think of the reverse. The lower the temperature, the more layers you put on. So this is called negative correlation, because as one amount increases, the other decreases. And you can probably guess a graph that shows negative correlation is one that has a negative slope. Okay, so we would say this graph has negative correlation because its slope is negative. All right, one last type of correlation is just no correlation. What is the relationship between how much money someone makes and their favorite sport? Well, there is none, okay? You could have a lot of money and love football. You could have no money and love football. So the reason this is called no correlation is because there's no relationship between these 2 topics. A graph that shows no correlation is one that shows no pattern between the 2 points or between all the points, and they tend to be all scattered. All right, so let's try some practice here. So we're going to determine the correlation of the following, and your answer will either be positive, negative, or no correlation. In number 1, we see all the dots are kind of scattered everywhere. This would be an example of no correlation. In number 2, the dots appear to be going downwards, so this would be a negative correlation. In number 3, the dots are going upwards, so this is a positive correlation. Now let's look at some different situations. Eye color versus age. These things are not related, so this is no correlation. Hours you work versus money you make. Well, as your hours go up, the amount of money you make goes up as well, so this would be positive correlation. The amount of water in a barrel versus the time on a hot sunny day. Well, if it spends a lot of time outside, what happens to the water? It evaporates, it goes down. One's going up, one's going down. This is negative correlation. The amount of time you spend on school versus your grade in school, in general, this is positive. If you're coming to school every day, if you're working outside of school on your assignments, a lot of times you're doing much better than people who do not come to school and do not work on their assignments. Number of cars on a road versus the speed of the cars. Well, think about traffic. If there are a lot of cars on the road, they're all going pretty slow, so this would be negative. And finally, the time you spend working out versus the percent fat of your body. Well, if you work out a lot, that percent fat is going to drop. And so since those are opposites, this is negative. All right, so 2 more vocab terms for you. You may have heard these in your science classes. So we have something called interpolation, which is estimating within a data range. And we also have something called extrapolation, which is estimating outside of a data range. All right, so let's see how we could use this. Jerry's average points per basketball game for the year 2012 to 2020 can be estimated using this equation right here. Let X represent the number of years since 2012. Estimate Jerry's average points per game for 2019. Okay, so we are comparing to year 2012. This is like our year 0. So the first thing we need to figure out is how many years have passed between 2019 and 2012. So to do that, we just go ahead and subtract, and we should see that there are 7 years. And now that 7 is going to go in place of X. And then we're just going to type this into our calculator. And we get 16.4. And this is points. Now, whether we use interpolation or extrapolation, even if you aren't able to get the answer to letter A, we can still get the answer to letter B correct. That's because interpolation and extrapolation is having you look at your data range. So our data comes from 2012 to 2020, and now this number that they've given us is 2019. So all you have to do is decide whether 2019 is in between these 2 data ranges or outside. 2019 is in between them, and that makes this interpolation. Interpolation for inside. All right, so now we're going to go ahead and we're going to estimate Jerry's points per game for 2024. Again, we're starting at 2012, so let's go ahead and subtract those 2 values to see how many years have passed. This is 12 years, and now that's the number that you're putting in place of X. And then we'll just type it straight in. And we get 17.4 points. All right, so now I'm going to look at the year 2024, and I'm going to come up and look at my data range. 2024 is later, and so that means this is extrapolation. All right, that's your introduction to correlation. I hope you have a great day. Bye.